So I'll give a little introduction about myself and then open up with an overview of what I want this session to go like, and then we can get into some stuff. So my name's Hareem. I'm coming here from Toronto, actually. So it's super warm here. I work for Munich Re, and I work on the individual life reinsurance side. So you know how insurance companies insure you? Reinsurers insure insurance companies. So it's insurance companies all the way down. So I primarily work on a Python-heavy team using machine learning for underwriting analysis, mortality prediction, and claims management. And if you're interested in any of these or are looking for a job, we're hiring interns, data scientists, senior data scientists, machine learning engineers across the board. And we have an office in New York if you don't like Canada. So there's that. And with that, we'll get into it. So the motivation for putting this talk together, it's a super novice talk. And I'm going to go through very basic things that took me a long time to understand when I started working with Docker. So I found that before I was at Munich Re, I used to be at the University of Chicago Center for Data Science and Public Policy, where I worked with like a very sophisticated team building early intervention systems for police departments, such as we worked with the San Francisco Police Department, Charlotte-Mecklenburg, and there was the first time that I saw Docker being used at like Docker and pipelines running Luigi and like really complicated fancy stuff. And when it came down to it, my interaction with it was quite surface. Like I'd build my model, I'd put it somewhere, and someone else would like go in and work with it. And that was my first exposure. And then I started at Munich Re, and we have a pretty strong data engineering team. And most of our DevOps stuff, like you hear Docker all the time, everywhere. So in those complicated use cases, like Docker makes so much sense. But then I found that a lot of issues I had with things like even working within our data science team. For example, managing 6 different virtual environments for 6 different projects I'm on. That could be easily resolved using something like Docker. But I found Docker really hard to get into. There's like a lot of language around it. There's not a lot of there's a lot of really good tutorials online, but you have to like sit down, go through, and like sometimes there's information missing that you fill in over time. So what I wanted to do was use this time to show you, to walk through some very simple Docker overviews, present a potential use case and a solution for a reproducible environment, and also one for running a very simple model. And you'll see the model deployment thing. It's just a template, and in that you can put your own pickled model, whatever, mount as an API, put it on Azure, AWS, anything. So just the background, we're going to integrate Docker into some data science workflows. It's open source, and the greatest thing that it offers is it allows you to build, deploy, and run your applications in this container framework. And the best thing about that with everybody moving to a cloud resource is that you can then easily port your applications so that they're live. And if you do any of the following, you have to share. Even if you work in a research role, someone has to be able to reproduce your analyses. And I've had many instances where someone has a different version of pandas and my metrics look different and it doesn't make sense. And it's like because it's dependent on a NumPy variation or something. And then also run large-scale data cleaning tasks where you just want to spin up a container, read all the data in, and write it all to your database and not worry about managing. And you can have your own workflows otherwise. And also building dashboards and publishing models. So I did this project with the Seattle Department of Transportation where we took all of their data coming in about bus stop usage and all the shape files and everything they had. And then we built like a shiny dashboard on top of that, and we wanted to be able to serve it to them in a way that made sense. And they had a lot of issues with like us hosting it on AWS and whatnot. So what we ended up doing was Dockerizing everything and giving it to their IT department, and then they could deploy it in whatever environment they're working in. Like I think they had like Microsoft servers, which I was like, I don't even know what that is, like Linux or bus, right? Like, so that was really easy for us, and that was the first time I saw where Docker could really make that transition really easy. So I've got a bunch of instructions up on this GitHub, which if you can navigate to it. I did ask if you installed Docker and Git before, but if you didn't, that's fine. I just want to walk through. So if you clone the repo, we can start. Yes?
How do we get to the URL for the repo?
Oh, it's this one right here. Can you see it?
No. Oh.
Okay.
Definitely not.
Oh no. Okay. Let me put it on Drive. Yeah, I didn't think through this kind of stuff. Is that better?
Much better.
Okay. And while you guys are going there, what's like the makeup of the room? How many people are students? Okay. Active data scientists, engineers. Cool. All right. Is everyone there? Okay. So the first thing I want to start with is this Docker start notebook or folder, and then we'll go to the titled dockerclient.org. So if you were able to install Docker before, just run docker run hello world. That's like the basic instruction they give you in the installation too. Oh, yeah. Oh, sorry. Did I take it away too quick?
If you just search your name and GitHub, you can go right there.
Perfect. If I'm going too fast, too slow, just let me know. So I will be doing it with you as we go along, and if anything breaks on my end, we'll figure it out. It's a live demo. We'll see what happens. Is everybody kind of caught up? Yes? No? Okay. Well, I'm just going to get started, and we'll see what happens. Okay, so I have Docker installed on my machine. I will just go type in this command. Oh, look, unable to find image. It's going to pull, and then it gives a lot of verbose instructions. So this is a very basic command that Docker lets you figure out what's going on, and this is kind of telling you that your installation is working correctly. So how many people are actually going to be following along? It's okay. Oh, awesome. And does this work for everybody? Everyone's at the stage? Okay. So the first thing we're going to do is we're going to run our first container. So this will be the primer or the background for when we start talking about all the terminologies like images, containers, clients, daemons, and whatever that is. So we'll start, and so in your terminal, you just type docker pull Ubuntu. This is where it's going to go, and it's going to download this image. So essentially what's happening here is that your Docker client, which is this like Docker run commands and everything you're working with, it's making a call to Docker Hub, which is a public container registry, and it's looking for this container image that's tagged Ubuntu. And it always pulls the latest image, but if you want like Ubuntu 3.6 or whatever, you could pull that exactly. And what that looks like on your end is if we just go Docker Hub Ubuntu. So where this is pulling from is all of these. So here's all the supported tags. So if you wanted the 18.10 image or something, you can pull that exactly. And this is maintained by the people who provide the Linux distribution. So this is where you're pulling this container from. And if you got any of those like permission issues, just make sure you run that one command to make sure users are up to speed. And so now I've downloaded a newer image for Ubuntu latest, and now I'm going to see what images I have. Oh, great. I have so many images, and the one I have here was Ubuntu from 2 days ago. So that was the latest. I already had the latest. So it should show you all the images that you have available to there. So now that we've downloaded our image, so also all the instructions are in this, like the GitHub, so you can follow along there if I'm going too fast or too slow or something. So now we want to run our container. So we're going to write docker run Ubuntu, and we're going to do echo hello. I don't know what happened. Okay. So what happened here was your Docker client it looked in your local workspace for this container Ubuntu, and in that it spun it up, passed the command that you wanted to run, echo hello, through it, ran the container, streamed the output back to your client, and shut the container down. So this is why Docker is fantastic. Now imagine setting up a virtual machine, however you do it, setting up a virtual machine, waiting 4 or 5 minutes for it to initialize, installing all the dependencies, setting everything up, and then running a command, and then shutting it down again. So this kind of quick start, quick collapse structure of Docker is what makes it really fantastic for working in some of the DevOps stuff, where you just want to spin up a machine, run everything through, and make sure everything is working. So here's your output. We ran in the Ubuntu container, we ran hello, and it came out. So here's a little bit more exposition. The Docker client calls the Docker daemon, which I'm not completely sure what that is, but I know it's something that manages the relationship with the API of how Docker's set up. So it's going to check locally if the container exists, and because we downloaded the image just prior, it'll build it, creates the container, and runs the command you specified, and then the output of the command gets streamed to the client, and then the container gets shut down. So maybe you don't want the container to shut down immediately. You'd actually like to work with it. Yes?
So I don't see the running a container. I don't see the full instructions on the repo. Am I maybe on the wrong URL?
Yes, this is in, if you go back, it's the PyData Docker
tutorial.
Docker start, and then you're an OO Docker
start.
client.
Okay, got you. Thank you.
Okay, I should have labeled those properly. Say you work on a Windows machine and you're building something that is going to be deployed elsewhere, and maybe they're running Ubuntu, and you want to see what that looks like. So what we can do here is we drop into our Ubuntu container right here. And you can run your favorite command essentially in here, whatever that is, and you can see everything that's there. And you can play around with this here. And now you've got this very lightweight Ubuntu machine just running on your machine too. So that's one very specific use case of what a container just looks like. You can install things in here. You can take them out, and to exit, you just type exit. The one thing that is great about Docker is because all the instructions are specified in, so the reason that the Ubuntu images are tagged 18.10, 18.14 is that they will update them over time, and all they have to do to update them is change the Docker file. So just the set of instructions that builds that image. And we'll go into all of that. I'm just trying to prime that discussion later on. And then, so far we've pulled an image, we've run a container, we've dropped into a container and messed with it interactively. Now we just want to recap what's going on here. So we want to see what containers you have going. Oh, that's weird. We don't have any containers going. Remember, every time you exit a container, it shuts down. So we don't have any running containers. But if you want to see what containers you have run on your machine, you can see these right here. So the one we just ran, the command, and about a minute, and then the status that it's been exited, and then it just gives it a name because I forgot to give it a name. So I think it called it gallant pear or something. Anyways. So here's background of all the containers that your machine has run. Now remember before we pulled an image, so what does that image store looks like? So let's type Docker images, and we'll see here we've still got that image here. So mine is from a few days ago when I was workshopping this. And we'll see what's going on there. Okay, so if sometimes the images can get huge depending on what you're running, like for example, if you have a Postgres image, which we'll build later, they can get very big. And so here's some commands that you can use to clear out the images and the directories and whatnot. So this is like very going through just what Docker looks like. Here's an image, here's a container, what it means to run, what a client is, what a daemon is. And so here's a bit of a review of that before we start talking about how we work with Docker. How do we build our own image? How do we build an image that I'm actually going to use? So here's like the image. It's a blueprint for the container you want to build. It's often based on other images. So the image we're going to construct, for example, you want to build an image for Python 3. So that relies on Python 3, but you install a bunch of other libraries that maybe aren't in the base. So you can pull from the public Python 3 image that exists on Docker Hub. So, and then make modifications to it with layers. And these layers you communicate as instructions in a Docker file, which is a very specific syntax and layout. Remember, container, it's built from an image. You pull images, you run containers. And then the Docker file has the instructions for how to build the image. And the special syntax, it's well documented by Docker, and you can go there and check it out. But sometimes it gets pretty deep, so I kept it very surface here. Then the other things of how Docker Hub works. So everyone kind of knows how GitHub works, right? You have code, you version control, you push and pull. So Docker Hub works exactly the same way, but the files you push and pull are these Docker files. And so say I have a version of a product or a project, and the scope of it changes. And so maybe some of the libraries or dependencies change. And then I have like this legacy code that maybe necessarily won't work in the new framework or my new requirements that I have. So I can have versions of a Docker file and ask somebody to install a specific version for a project. And Docker Hub is the public free container registry, but Azure and Amazon Web Services have their own private container registry. So for example, all of our DevOps and everything happens on our private container registry. And so whenever we have like a standard set of tools we use when we work with when we work on doing like mortality prediction or geocoding. So we'll pull the maintained container that has all the libraries we need to work with those packages. And one specific use case we have is when we're working with a lot of spatial data, we'll need base libraries like libgeo and gdal, which everyone doesn't necessarily have installed. So that's another use case. One very specific use case that I really like, because it kind of shows how you don't really have to, once you have like Docker set up for a specific use case, you don't really have to worry about it. We used to get these file formats from a client in .xls, and that's some outdated version of Excel that doesn't really work anymore. Like you can't open that up on a new version of Excel and run that file. And so we had no idea what like data set we were getting and what was going on. So the only tool we found that worked with it was in the genumeric library. There's a tool called ssconvert. But genumeric is just like huge, and I don't want to put it on my machine and work with it. So we made a Docker container, XLS to CSV, and all that does is you pass it a string for the file that you want to convert, and we store it in blob storage, or you could store it in AWS and S3. And it builds this container, runs it pretty quickly, and we maintain it. So you can download the latest version. And that has genumeric installed and everything it needs. And all it does is it passes the file through ssconvert and then outputs it as a CSV. So that's like a reproducible data cleaning task that we were seeing across multiple projects. So by having one Docker file or one Docker container that someone could just call and pass their parameters and their files and outputs, we saw that that made it a lot easier to kind of transfer these tools instead of building a package and having them install specific things and running it through. That's just like one use case that I think is pretty motivating. So I'm going to go through a Docker file. It's not the best example of a Docker file, but I think it's an interesting example of a Docker file. I've got like 3 Postgres's installed on my computer. Postgres is an open source database, and I find it really difficult sometimes to work with different versions. So I have this Docker file that I'll go back and I'll open it up. And what it lets me do is work on a Postgres machine and with PostGIS installed. So I'm developing code that works against our database that's deployed in the cloud, but I want to develop locally, like make sure it works and makes sense. So what I'll do is I'll pull from the Postgres image. So let's go back to here. And I've just listed a few of the instructions that it has. So Dockerfile, the way you'll see it set up is it'll be like from Ubuntu, from Postgres, from Python, from, and then you can give your container registry name and then exactly the path you want it to download. So this is kind of the magic of Docker, is that people say. It specifies the base image that you will be building everything off of. So if I'm working on, I don't know, I'm making a Shiny app, and I have like figured out how to deploy Shiny server so I can test it and make sure everything works. So if I have that Shiny server specified in a Docker file, I can tell someone on my team to just say, hey, just like pull from this Docker container in our container registry. One specific example is sometimes people on our team like to experiment with the XGBoost, and that requires G4tran and those kind of files. So we have a container that's specific to running an XGBoost model in production. So it can be a little bit more lightweight in that sense. So we're getting this from statement. And I'll go over, this is kind of how it works. So this is like what people accept as a Docker syntax. So you'll have the instructions capitalized, and then the arguments are in lowercase and whatnot. And it looks relatively neat, or how you're supposed to do it. So these are the 2 main commands, from and run, that I consider the workhorses of Docker. So from specifies your base image, and then run lets you, it just essentially runs shell commands. There's nothing specific about this that's Docker specific. It's just a bunch of shell commands that'll go and I'll update, install PostGIS, and set up Postgres PG routing. And then, so in the same kind of way, yes, sorry.
Are those examples of layers?
Yes,
The terminology?
yes, exactly. So your base image, and then as you go down, add instructions, those are layers. And then the other thing you can add, and a lot of people will have, is a label statement in which you add metadata, and that could be anything. It could be the name of your container. It could be your email address. A lot of people put it so that they know who to contact when they have issues with the container, or there's some dependency that they think is missing to run the code. Again, the run statement, in our case, we're just using it to run the shell commands. Another command you'll see often is this work dir command. So it's not sued, it's used. It's used to specify working directory, so any other commands you give following it, you won't need to specify the path. And there's also the add statement, which is very helpful, which lets you copy files from your host machine to the Docker container. So I've also included references in the README of like the main tutorial file, which takes you to such green pastures as adding volumes to your Docker container. So you can have it so any changes you make in your local repository will be synced immediately. For example, you want to change the data file that it's being processed through, you can just update it there. It gets a little complicated, so I wanted to keep it simple, but if you are interested in figuring out how to link your container environment with your context, you can do it through those. And then the other thing is the CMD statement, and it provides a default when you're dropping into a container. And you can only have one valid CMD command per container, and if you provide several, only the last will be used. And there's more information at this link, but I just wanted to go through these. So from, label, run, work dir command, add, CMD, those are all the commands you're going to see today, and in my opinion, I think those are all the ones you need to get started. So now that we have this idea about kind of what Docker is. I'm going to pause for a few questions if anybody has questions up to now. Yes?
This is more like the best practices. If you're starting like a really new project, do you have like a general purpose analytics Docker container that you spin up, or do you sort of, I don't know, how do you partition that workflow?
So I don't have a good answer for that because we don't have best practices on that. But when how we work on our team is we have these virtual machines that can be destroyed any day. So what everyone has been told to do is you keep a Docker file that specifies all your system level dependencies and configurations. And if that gets down, you can pull from the latest image. And so you'll be able to replicate. And all our code, well, we're an Azure shop, and Microsoft is all about vertical integration. So we use like Azure DevOps, which is, they bought GitHub, but it's like the face of GitHub or whatever on our end. So that's how that works for us. Because data doesn't touch our virtual machine, and like code is version controlled, so you can pull your repo as it happens. But all those system level stuff, we'll keep a Docker file and an image in our container registry. But that's a good idea if you're like starting any analytic. So for example, you're building a Shiny app, that you need all the same things every single time. So why not just run it up? Yeah, that's a good idea. Any other questions? Okay. Ooh, I don't know why I pushed IPython up. It's fine. Okay. So how many people work with virtual environments? Virtual environments? Okay. Do you ever get the issue where you're stuck with managing 6 different virtual environments? And you've got like 4.
6,
yeah.
16,000?
Exactly. And then you've got the issue. So like when I work with virtual environments too. I use like PyEnv to manage everything. And it seems to work fine most of the time. But then I'll say something like, oh yeah, just pip install this requirements file, and everything should work. And it often doesn't. And I say just, make a new virtual environment, pip install, and then everything should work. So I'll give you an example of something that happened last week. Most of the analytics work we do happens in like Jupyter notebooks for exploratory analysis. So I push all my analytics code, and I'm like, here's the requirements file. Everything should work. And I just need you to do peer review and make sure our work makes sense. Because like for regulatory reasons, we like have to go down and make sure any code we commit has to be peer reviewed in that sense. So my teammate goes to check. He's like, my version of pandas is off. It doesn't work, blah, blah. I was like, hey, why don't you use this Docker file? Build the Docker container, and everything will work. And it did. So that was a motivating example there. The other thing I often get is my virtual environments tend to break, and I don't know what I'm doing, and I don't want to probe too far. But this seems to work for me. So I put exactly the issues we've seen. Is someone builds a tool in a different flavor of Python with several package changes, and someone is developing something like a random forest explorer or something, and that requires some graphics library that nobody else has installed, and you have different versions of things. So that's what we find. And the use case we'll explore here is setting up a Python, like spinning up a Python container with all the tools required for a project, and then setting up a Jupyter Notebook server with access to all of those resources. So you can imagine you have this Docker container that also has the Jupyter Notebooks you need to run things as required. So let's go over the Docker file. So this is a little bit of a more expansive Docker file than we saw previously, which just had a from and a run command. So let's go through it, and I'll talk about this. So the from command, we're pulling from the Python 3 base image. So if you go on the Docker Hub, you'll be able to see where this is coming from. And then we're just checking for updates, and we're installing pip. And then remember, there's add and then there's copy, and they kind of work the same way. So here, there's a shortened requirements file for the project I was working on. And what I've done is copied requirements into the Docker container. That's what that does. And then I'm running pip install, and then installing the requirements.txt. And then I'm also running pip3 install Jupyter. And the other thing I do here is because we don't want Jupyter to be on root, just for security reasons or whatnot. You don't want to break anything too badly. So we also add this demo user, change to the user, and then specify the work directory, and have given a different flavor of a CMD command. You can also call it entry point. And these are just, so for example, if you're running a Jupyter notebook in your terminal, you may type Jupyter notebook, whatever. This is just another, so what's going to happen, the Python base image will be pulled. It's going to run all of these. It's going to copy the requirements over. It's going to install all the requirements, then install Jupyter, make a new user, switch to that, switch to a new working directory, and then run the command Jupyter Notebook inside your container. And we'll launch a Jupyter Notebook server. So if you want to go ahead, the other thing about Docker containers is you have to specify the path to your Docker file. So everybody should now be in this dev.env folder on your machine. And so it's going to build this environment, tag it dev.env, and then this dot specifies that it's going to set the context. And the context is just where your Docker file is located, and all the files that you're calling in your Docker file are located. So,
Quick question.
yes.
Could you replace that entry point call with a command call to the same effect?
Yeah, it's just switchable. I just want to give a different example too, because you'll see it in many things. So we will do this here. Oh, see, this is the error you get if you're not in the correct context. So there's no Docker file in this directory, which makes sense. So I'll switch to dev.env, and now I'll do docker build, and I'll tag it dev.env, and because I already have it, I already built the image, it just runs through, and this is what it should look like. So if you guys want to go ahead, whoever's following along, just build this container. And then we will just I think it takes some time because some of the packages take a while to install on your machine. So it's probably just running for you guys. Any questions while we wait? Okay. And I won't get to it today. Yes?
You didn't have to do work directory prior to copying in the requirements.txt because you're just presuming current work directory. But if we needed to specify where to get the requirements.txt in the Docker file as a different location or path than where I want the Docker to eventually run, can I do the work directory command twice and does it sequentially replace? Or how would I?
Yes, so it would replace it for that run command if you go down multiple run commands. But workdir I find is like more helpful for running just before you're about to initialize your like final command. And you can only have one of these final commands, right? Like this command or entry point. So we'll see when we deploy the app or the model later on is that you just use it to call Python main.py, right, at the end. And the path that you pass here, this like I want to copy this to this, it has to be respective to the context. And the context is the folder that your Docker file is in. So we're in the same folder, so we just pass requirements.txt. Yes?
For these base images, is it standard that they're Ubuntu, or are we just selecting this? 'Cause, like,
It's standard that they're Ubuntu, I think, most of them. So there's also like base Microsoft images that I've never messed around with. But if you're developing an app and you want to see how it does there.
Is it like a Windows or like the Microsoft Linux that would refer
It's
to?
a Windows machine, so you can test deployments there too if you don't have access to all of those. And I think a lot of testing tools that test different environments use Docker on the back end too. You guys know what Airflow is? Like the pipeline management. So they also, no, sorry, not Airflow. Pachyderm. Okay, so it's kind of like it's a pipeline management tool, and I've been playing around with it a bit. It's a little complicated, but they use Docker as their backend. So you've got like your task graph, and it'll go down, and each task is a Docker container, and it kind of exposes all the user functionality of Docker. So you, for example, you could have a data cleaning Docker container that's triggered every time someone drops data in your S3 folder or your blob storage if you're using Azure. And then that data cleaning Docker file gets run, and it writes outputs to your database. Then when your database changes, it spins up another Docker container, which will run all your modeling tasks, and then write results back to your database. And then it spins up another container that like output a report. And Pachyderm manages all of those. You can also manage it yourself using a tool like Docker Compose, which I use to serve apps that have maybe like a database Docker and then also the front end Docker. But Pachyderm allows you to manage like that specific task graph, which is pretty cool. Everybody kind of, it works? Yes?
So I have another saying that Docker build requires exactly one argument.
Sorry?
Docker build requires exactly one argument.
What argument?
Yeah, I mean, when I try to run that particular code, like
Yeah.
Docker build deven, it's saying that Docker build requires exactly one argument.
Oh, okay. Did you pass it like -t deven, because you're tagging the image, and then there's also a period there, which maybe you missed?
Yes.
Yes. Because what it's missing there, I think, is context.
Okay.
Did that work now?
Yeah, the dot work.
Okay. So once you get that set up, so I'll just show what the other interface looks like. So we're going to run, and Docker's weird about ports. You should read up on this. I don't fully understand it, but so in this Jupyter server is running, but you have to map the Docker 8888 port to our local host, and then we'll do that. And what else will we do? Okay. And we'll pull devenv. Okay, great. We're running a Jupyter notebook inside this Docker container, and we can access it by just going to this. Should I just paste this? So here's the Jupyter notebook that's running inside this Docker container, and no matter what flavor or whatever your machine runs, it has all the same Python packages installed, and it has Python 3 installed, and you can open it up and work with a Jupyter notebook here. So, does everyone get that? We can go back to. So the container is running on your machine, and you've got this notebook running on that container. Remember, it's ephemeral. Right now we're running it, and now we're like, okay, we don't care anymore. It's going to shut down the kernel. So not only is the kernel gone, but also the notebook that you built. So if we see again what containers are running, no containers are running, but we see here is the devenv container that was created about a minute ago, and this was the command that we ran in it. And it's been exited 10 seconds ago. So that's just another example of you had a Python container, you installed a bunch of requirements, you installed Jupyter on it, you served a Jupyter Notebook server, and then in that you had access to all of that. And you can imagine how if you had some notebook on your machine, you could copy that over into the Docker container and have that available to you with a specific set of dependencies in there. Okay. Any questions around that? Yes?
So, file, of course, untitled that you created is gone once the Docker is exposed. So you just mentioned copying a local notebook, which you would then have access to. When you want to explicitly preserve changes in the Docker, is there an ability to kind of add or put it back out of the container or back out into the global environment, or
Yes.
push a file back out?
So you can mount volumes to your Docker container. So that will mean you'll, for example, you could have Python script that you make changes to, but it runs in the Docker container. It doesn't run locally. So you make changes to it, and the changes persist in the container. So the volume is mounted. And if you follow some of the instructions on Docker, like their actual website, it's a lot better explained than I would have time to do in like an introductory. But that's a really good question, because that makes a big difference in managing your code and whatnot. Any other questions? Did this work for everyone? Were they able to get whoever was able to do it? Yeah, that's the thing with like the live stuff is I've stress tested what I was going to show like 7 million times, but I'm not sure if it would work for you. The whole idea of Docker is that it should work for everybody, but I don't know. Sometimes it doesn't always work. Okay, so I want to leave about more than about 25 minutes at the end or half an hour for questions. So I'll go through, or if anybody got stuck on something, and also we can talk about some like really advanced Docker use cases that, for me at least, are aspirational, but one day. So if you want to switch to this folder called model deploy, I'll just go through this Docker file here. So this is a template for how you can use Docker to set up a Flask app and serve a Python model. And essentially, you can serve it in such a way that an external application can then make API calls to it, providing the feature values and get a prediction. And for us, at least, this is a standard way that we'll deploy, because we have a lot of insurance companies who are our clients, and we'll do things like build smoker predictor models. So based on seeing this many fields, can we predict whether or not somebody's a smoker and whether they should be routed for further testing? So on that end, their agent on the insurance company side has to fill out like a bunch of questions, and they have the other person on the phone or in person. So they need a real-time response. And so they'll enter a few values. It'll make an API call to our model that's deployed, and then in their UX, it'll display directly the smoker prediction, but parsed in a way that they'll be able to make a decision based on that, whether or not they should pass this person on for further screening. And that's a very simple way to deploy a model. It requires a very specific specification, but it's a really stable way of deploying a model for external consumption. If you look on any of like Airbnb has that, and Uber, and they have all these tools like Michelangelo, and they have their own architecture. But this is how you can build quick models quickly and serve them without too much infrastructure or being locked into like a feature engineering wizard or something in place. So we'll just go through. So I'm pulling this image that has Flask and Ness and runs Python 3.6, specifying the work directory, copying my requirements over to the app, running pip install. And then the other thing I do is one thing I didn't mention before, is setting OS level variables. And here I can do that using env. And first I specify the variable I want to set and what I want to set it to. And then I copy over my main.py and my init.py into the app folder. Any questions about this container? So this will give us everything we need to build this. And I'll go over to my main.py and we'll go through like what that looks like. So I do like all of the imports, Flask, request, linear model data sets. And then so the data set I'm going to build this model off of is the diabetes data set. And this is very simple. I just train on everything and use one feature, just to give an example. So I take just one feature, and then I create just this linear model, use this one feature and the target, and then I do a pickle dump. And then I specify my app. I specify this like is alive just to check the app is live. And then I specify my prediction endpoint, my API endpoint for the prediction, and then specify what these arguments look like. So it's going to, the argument is f, and then it's going to open the model and then run the prediction on it and return this prediction. And then remember before we set the environment to be production, what that's going to do is it's going to specify that you're running on port 80 and the host is local. And I just use that to specify another variable for Flask. And in requirements, I've got NumPy, SciPy, Flask, Pandas, scikit-learn. Nothing too complicated. So let's go here. I didn't put any instructions in that. That's not helpful. So we go back, and we'll go to model deploy. And remember, we start with the build again. So docker build -t, we'll call it model, and we'll do that. I've already built the image, but this is what it should look like for you guys. So it's doing all the steps that you specified. So each layer is being added. I think it takes a bit of time because scikit-learn takes some time to install. I could do one thing here. So I'll show you what it looks like when you change your Docker file. No, I'll change my requirements. Maybe I'll add, what should I add? Something small. I'll add like census geocode. So now let's see what happens when we go to build the Docker. So look, everything that was cached has worked, like my copying my requirements over, but since I changed this requirements.txt file, it's going to run this version thing again. So that's a good way to see how things change. I don't know if this is a great idea. Census geocode can take time. But at least this puts me kind of on pace with how people are following along or doing.
I have a question.
Yes?
So the top of that Docker file has what looks to be like a custom Docker base.
Mm-hmm.
How do you go about making your own custom Docker base, and what's the advantages of doing that versus?
So how that TN Golo is a maintained image. This image that I have now, this Docker file, this could be a new base image. I just have to push it to Docker Hub.
Okay.
So do you remember that Postgres image we saw? I can go back to it, because that's a good example of making your own base image. Because say I want to work with PostGIS in something I'm working on. So that lets me work with shapefiles a lot better. So this is a good example of a new image that you've made for yourself that's very basic. And so somebody could now pull this image, whatever, you can tag it like PostGIS, upload it. Somebody could pull that and then run their queries within that file, within this image and container. And again, it's open source, so if you want to make some changes to like the base Postgres images, you can push your own changes too. So we'll go back here. Okay. So this model build happened, and did it work for everyone? Is it going? Yes?
It's not regarding this, but I was unable to run the Jupyter notebook.
You're what, sorry?
I was unable to run the Jupyter notebook.
Oh, it's running in another Jupyter notebook?
I'm unable to run it. It is asking for some token authentication.
Oh.
First time that you go to your browser for Jupyter, you may need to actually copy the token from the
Yeah.
command line. It'll give you the token. You might need to copy it in the first time if you've never run Jupyter on your local machine.
Okay.
First time opening Jupyter here. Run it there.
You copy and paste it over, it should work. Okay. So now that I've got this Docker container build, I would love to see what it looks like when I have a model that's live. So I'll do Docker run, and I will pass this port to 80, just so I can keep track of stuff. And I will run my model container. And because in this one, like you spin up like this server essentially, it doesn't shut down. So now we'll navigate to localhost 1000, and we can check here. Yay, it's alive. So it's up. And now we can also check prediction. Great, we got a prediction. So if you were making API calls, you could specify your API calls. I'm just doing it in the browser because it's easy. But you just change this like feature value that, just to clarify everything. We'll go back here because I think maybe I went a little too fast. So at like when you specify things in Flask, you specified that you're going to get this argument f, and that is what I passed here. I went to this port that I'd opened this like prediction that I'd set up, and then specified the first argument f equals 0.05. And I can change this 0.07. I can change this 0.04. Whatever is within the scope of it. And I think even negative values are within the scope. Yes, and I'll get a prediction. And I think this is the diabetes data set in scikit-learn. I forget what the actual target is. It may be some GFR rate. If you can't see that, I'm very sorry. I will paste it here. There you go. And this is just like a quick way to see that your app is live, it's running. You can pass arguments to it. So what's actually happening on the back end is you're sending this argument to this pickled model object, and it's returning the prediction of running that model, of like loading it, and the model.predict. So you can imagine you have a model with like 20 features, you spec it out, you specify all the inputs, and yes? Oh, okay. You specify all the inputs, and if, for example, our client on their end is inputting all these values by hand, we have the spec very carefully, and it just makes the API call, passes all those variables that were input, makes the API call, returns the prediction, and returns it to them after that GET request. And most UX backends will allow for that.
What port did you map again?
Oh, I just mapped 80. So you just wanted, so the command I ran, I'll just exit this. This is the last command I ran. So I mapped port 1000 on my local machine to 80. I could have mapped 80 to 80 because this was the port that was specified in our main.py file. Yes?
I saw that the build that you took was uWhiskey, which was actually hosting the Flask. And this is circling back to my previous question. So the uWhiskey workers are also within the container,
Yeah.
not in the local.
Yeah.
So you have multiple workers inside the Docker, server spin up. If multiple Git requests come in, you could have two simultaneous with the workers. And yet, both the Flask log and the uWhiskey log will disappear when the Docker comes down.
Yeah.
So you have to explicitly mount to get logged to know, hey, how many people hit my prediction? How many people were smoker yesterday? How many people were not smoker yesterday? You don't explicitly do that.
Exactly. So to clarify, I would not deploy a model with like a Docker container that's up and down. This I use to test mostly. What we will do is we'll use an API management service within Azure. And your Docker container will then be the template for like a virtual machine that's going to be running. And it's going to be serving, and they'll persist. And your logs will be stored, and we'll write the logs back to like the equivalent of S3. And then so we'll set that process up.
I see.
Yeah.
So this is, again, very much a dev paradigm.
Very much a dev paradigm, just making sure everything works. So if you want to test something there. And you can see how, like, once you have this running, you can just copy that over to Azure Apps or whatever the equivalent in AWS is. I keep missing them. I know, like, Azure is like a feature-by-feature ripoff of AWS, but I always forget which one is which. They need to, like, publish some mapping. So that's essentially how this whole Docker paradigm, those are the two most important use cases I see. I have worked on projects where so Luigi has really good integration with Docker. And for each task that we wanted our pipeline to handle, we would write specific Docker containers to manage all the dependencies and whatnot. And then you can use a container orchestration layer and run and deploy all those apps at scale. And one of the best things about that is if you're running like 1,000 models and you want to parallelize that, it's really easy because you can just set up a bunch of containers that'll run your modeling scripts. And if you write all your results and outputs to a database or something that's more stable, then the containers just disappear after you're done running it. So you don't run up like large costs on your cloud compute resources. Actually, did you guys know the horse that won the 2017 Preakness Stakes was called Cloud Computing? One of the members of my team sent me a fun fact for my presentation, so there's that. But yes. So that's all like the live demo I have. If there's any questions, we could address those. Or if you want to walk through kind of like what your paradigm is and where you think Docker could fit in or where you think there are some shortcomings, we could talk about those too. Yes. You have a question?
Oh, if she was first, I already had my turn. Go first.
Oh, no, I was just giving her a 30-minute. You're good.
Oh, okay.
Okay.
So the Flask stuff is particularly tricky because we use Flask a lot for some of our internal services in our company. And the Docker, it's very internal custom business needs, so there's a lot of iteration on it. So even though this is obviously a dev focus, we change our user interface for our internal clients a lot.
Yeah.
So this is very intriguing for that. When you go through a lot of changing of your Dockers, or you do a Docker that is deployed, so it's not dev, but that the client that constantly has new bugs, new features, new iteration, like obviously this lets you iterate yourself very well, but can you talk about like some of the pain points or stuff that it solved from previous experiences, or like some of the advantages of the very dynamic ability to like just switch the requirements file stuff? Like the build sucks, you have to go through the pain of building every time, but if that's worth the trade-off from what you've seen, or?
So I think it's worth the trade-off if you're doing something where like only your requirements.txt is changing, because they'll like cache everything up to there, right? And that versioning works really well. So I would say our data engineering team uses Docker the most because they're like developing and deploying a platform. So on their end, they have like a production environment and a dev environment. So all their tests are spun up in Docker containers, and they make like, they want to make sure all the requests work. So they'll send like 10,000 requests, and that's a test for something. So they use that, and they'll run their testing environment in Docker containers as required. So that's like maybe the proper like DevOps use case, and this is kind of like an ad hoc, like here's a way that this works for me, and it's kind of fun to play around with. Those very specific like technical things, I think it could work, but you would need to set in place measures, like so the same way like you have around code review and things like that, right? Like you just
change control.
Change control for environments.
Out, if you're not going to make them, if you push them to Git, if you push them to the hub, you have version control. But on the private, on your private, if you're changing containers, how do I know that somebody changed the container when I pull it again? If it's my buddy, if it's not like a repo?
So if you have a container registry, that is like a repo for containers. And
the private one will have a good one, like the log?
Yeah, it'll have the log and everything. So it'll have those versions, and you can tag each one. So I can tag like push version 1, version 2, 3, 4. And when you run your basic like Docker build, it'll pull the latest version and run that image. So it kind of works the same way as like GitHub would work. We also don't have like good change controls on that around our team too. I'm trying to be the evangelist for it, but I don't know what's going to happen. Yeah. Yes?
I've got a question. In all of these folders, it makes the Docker file executable when you run it, correct?
I think the Docker file is just executable if you have the Docker client. I'm not sure if you have to make it executable.
Oh.
It just looks for something called, if you don't pass So you notice that I ran this like dot command. If your Docker file just calls something not Docker file, you pass the name of it there. But if it's just called Docker file, capital D, lowercase everything else, it finds it and runs it automatically.
Okay, let me reword. Is it that Docker file executable, like in that in the model deploy folder, it made a Docker file executable? Is that what we would actually?
Oh, yes, yes,
That's what we would load up to run, right?
yes.
Okay.
Any other questions?
Can you do ls-ltr so we can see the files and permissions in the directory that you're in right now on the screen by chance? Docker files, nice.
Yeah, I don't think the Docker
Docker
file
file
is an
doesn't have to
executable.
be
I think, yeah,
It's
it
just a
doesn't
red
have to be.
file.
It's the Docker, if you pass it to the client, it's just a file.
Oh,
It manages all of that. Sorry, maybe I got confused.
It was just showing up. I must have read it wrong. It was showing up like with that executable thing when I click on the browser. It might not be there.
Okay. So do you think it's worth the pain of learning how to work with Docker to use it? If you test it out, let me know how it goes. And if anybody is looking for employment, come and talk to me, and we'll see what we can do. That's all I have.